Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. It's a very interesting question. That's why I have selected this. So I request everyone, please pause the video. Try by yourself and whatever answer you get, please write in the comment box. Not only the option, please write the explanation behind selecting this option also. Okay, I believe you have tried. So let's start. Now, what is the major product of this reaction? Reaction means this side is one isopropyl group and this side one methyl group. It reacts with concentrated sulfuric acid and concentrated nitric acid. What is the product? Okay, so first let's learn a little bit what this concentrated sulfuric acid and concentrated nitric acid mixture produces. Means why we are mixing concentrated sulfuric acid or concentrated nitric acid, because it generates a molecule NO2 plus. It is electrophilic in nature. I shall explain after some time. So here concentrated sulfuric acid acts as acid, means it releases H plus, and that H plus is taken by concentrated nitric acid. So you can look at the structure of this nitric acid. So by the way, do not get confused that why there is a charge separation. The reason is nitrogen cannot exceed its valency beyond 4. Okay, second row element, so it can't. Now actually if you look at, there are 3 oxygen, 1, 2 and 3. So any of these oxygen can undergo protonation. Okay, probability. But if the protonation takes place on these oxygen number 3, that has a fate. That's why I am selecting this option. So after protonation, means this oxygen abstract this proton. Why? You say, sir, nitric acid is a strong acid. It should give proton. Why it accepting proton? Because concentrated sulfuric acid even stronger than nitric acid. That is the reason. So that case, this sulfuric acid will act as acid and this concentrated nitric acid will act as base. Means it will abstract the proton and it will result this OH2. Now just look at this. Oxygen is an electronegative atom. It's carrying a positive charge, so it will not be stable. So what it does, this bond will break. What it comes out? Water, neutral molecule. Now sulfuric acid gives H plus, means what is remaining? Obviously HSO4 minus conjugate base, so that is written. Now water produced, fine. What is that after? So when water molecule leaves, then these oxygen pushes and produces a N double bond O and the positive charge on this nitrogen. How can you understand? Look at nitric acid was neutral. It abstracted on positively charged species, I mean proton. After abstraction of proton, it became a positively charged species, this one. So from this positively charged species, one neutral group come out. So what should remain? Obviously a positive charge. So that means NO2 plus. It's called nitronium ion. Okay, so this is acts as electrophile. Why electrophile? Because you can see a positive charge on nitrogen. So you can say, sir, it is electron deficient. That's why I'm saying it's acting as electrophile. And here this acid mixture combination is called mixed acid. It is used to generate nitronium ion. So now next question. Why this mixed acid reagent presence, why it nitration takes place? Obviously because NO2 electrophile generated. Second, why sulfonation doesn't take place? Because acid base reaction is faster. So during the reaction, instantly this electrophile is generated. So sulfonation not possible. But if you take pure sulfuric acid, then this electrophile generation not possible. That time only sulfonation takes place. Okay, so this is a doubt I believe you have understood. Now concentrated sulfuric acid and nitric acid produces NO2 plus or nitronium ion. So what it will do? See, it's an aromatic molecule. Electrophile is present. So what it will do? Aromatic electrophilic substitution. By the way, I've already discussed many lectures about the mechanism of these different substituents on biphenyl system, 5-member heterocyclic system. If you want to learn, you may visit those videos. Now let's come to today's discussion. So here if you look at, this is actually an isopropyl group and this is methyl group. By the way, both are electron donating group or electron releasing group. It means they will increase the electron density inside this benzene ring. So you can say this benzene ring is activated. This benzene ring in this molecule is more electron rich compared to the unsubstituted benzene. Means they are activated for aromatic electrophilic substitution. They'll react with the electrophile smoothly. Now second question, that where the reaction will take place. I mean about the regioselectivity. Actually if you look at, so where the reaction will take place. Now if you look at these are the CC bond, this one CC bond, this is also a CC bond. We know CC bonds are less reactive, they are stable, strong, so there will not. Now only two option, option 1 or option 2, this side is also same. So now where the reaction will take place. Now in this context there is a question comes that who is more electron donating, who will control the reactivity. Now if you look at this isopropyl group, it has only one benzylic proton, so only one hyperconjugation possible. But if you look at this methyl group, three hyperconjugation possible. Obviously there are two CH3, so plus I effect is stronger here, plus I effect little weaker here. But now question, who is more dominant here, hyperconjugation or plus I effect? Remember, hyperconjugation is more dominant, and you may consider hyperconjugation as a in between, like resonance plus I effect in between hyperconjugation. So compared to plus I effect, hyperconjugation is stronger. So obviously this methyl group will dominate. Point number 1. Second thing, if I say hyperconjugation means it's a orthopara orienting. So ortho means this position number 2, and obviously in para there is this isopropyl group, so no aromatic electrophilic substitution can take place. By the way, I am saying the word aromatic electrophilic substitution. For that purpose, presence of this carbon hydrogen bond means here also this carbon is attached with a hydrogen, that is compulsory. So first, where the reaction, so these bond will attack NO2, and first there will be a sigma complex formation. By the way, for detailed mechanism please visit the video I have already uploaded. So okay, this is the CH3, there is a positive charge. By the way, this positive charge is delocalized all over the ring and it is stabilized. Even if you look at this position through hyperconjugation, I mean, you may think that okay, there is one hydrogen, this bond will go and this H plus will remain closer to here. So in this way also this positive charge could be stabilized. By the way, I am showing only one structure. I suggest if you want you can try to draw by yourself. Okay, so in this way the positive charge is stabilized. There is hydrogen, there is NO2, and obviously this too. By the way, this double bond will also participate. I mean, it will come here, positive charge will go there, even from at there. Fine, I'm not going that much. Now in the next step, now if you look at previously the molecule was aromatic, this molecule. Now because of aromatic electrophilic substitution, this part aromaticity is lost. Aromaticity means a very high stability. Here stability is gone. So how can this stability could be gained? Because remember, every molecule prefers to have stability, and they always try to do chemical reaction such that they can attain stability. That is the main driving force, motivation for molecule to have chemical reaction. Okay, so here how can it have stability? So these 8 proton, this hydrogen is released as proton. I repeat my statement, this hydrogen is released as proton or H plus, means this bond pair comes here. So what it does, obviously this side NO2, this side the isopropyl group, and this side the methyl group. This is the aromatic electrophilic substitution product, and by the way this is the major product. Now whatever I told, the another one means substitution at this place, okay, it could be possible, but at this situation it will be the minor product. Okay, so this is the overall discussion. Now let's go back to our MCQ. So what is the major product? Look at whatever asked in this reaction. So obviously option B will be the major product. Now just imagine you do not know the exact answer or exact logic. How can you come to the right answer? Less than 30 seconds possible. Now you should remember that okay, this constant sulfuric acid or constant nitric acid mixture or mixed acid produces NO2 plus as electrophile. Where the electrophile will sit? Obviously it's aromatic ring, electrophile, so aromatic electrophilic substitution. Look at this, where the nitro gone? This replaces this hydrogen. No, it is not aromatic electrophilic substitution, gone. Next thing, what is this? This carbon-carbon bond got broken. Ipso type substitution, not possible here. So there are other alternate options, so these will not. Now in this way you have removed these two options, so your life becomes simpler. You have to find out one option between A and B, and one of them is the correct. So this process is called process of elimination. Using your understanding, common sense, you can release or reduce the number of options that will help you in the exam. Now question, who is more contributing, methyl or isopropyl? Obviously hyperconjugation point of view, methyl is more effective, and actually that's the case. That's why B will be the major product. I know this is easy question, but this is a confusing question too. So that's why please try to remember this information. It's important. Now this is the overall discussion. I believe this video may be useful. If you really consider the content is worthy, then please help this channel to grow. And if you have any doubt regarding the logo of my channel, I request please read this part. Your doubt will be clear. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.